Welcome to the MSBTE online learning platform. We bring you the most relevant content in an exciting digital format. Today, we will be studying a very interesting module from Applied Mathematics, Application of Definite Integration, which includes the topic Volume of Revolution, where we will be studying some interesting facts about applications of definite integration and we'll be practicing some of the examples based on it. So let us begin. Dear students, we have seen the first application of integration, that is the area bounded by the curve. Now, the module is application of integration and the topic is volume of revolution. Objectives: applying the knowledge of definite integration, finding volume of solid generated by evolving the x-axis, the area. Learning outcomes: students can find volume of any solid generated by revolving the given area. Volume of solid of revolution. Let y equals to fx be a continuous function defined on the interval ab, then the volume of solid obtained by revolving the area under y equals to fx between x equals to a to x equals to b within x-axis about x-axis is given by the formula v equals to pi integration a to b y square dx. Now, sometimes it is about y-axis. Then in that case, there is a small change in the formula, that is v equals to pi integration a to b x square dy if it is revolve about y-axis. So be careful in examination whether it is asked about the x-axis or about y-axis. In general, it is asked about x-axis. Now, see some examples. See, if a rectangle is revolved about one side, of its sides, we obtain a right circular cylinder as the solid of revolution. You know rectangle? If you revolve the rectangle about one side, it forms a circular, right circular cylinder. If you take semicircle and if it is revolved about x-axis, it forms a sphere. If a right angle triangle is revolved about x-axis, we can get a right circular cone of the solid of revolutions. In this way, we can find different types of solids by revolving the different areas about x-axis or y-axis. So the students, let us have some examples. Here is example. Find volume of sphere generated by revolving semicircle x square plus y square equals to 4 bounded by its diameter about x-axis. Here x square plus y square equals to 4 is semicircle. See the diagram. This is a semicircle which is revolved about x-axis form a sphere. So the area above the x-axis is revolved about x-axis. So the limits of integrations are minus 2 to plus 2. But this is symmetric about y-axis. So we can take half part of this and make it double, that gives the required volume by taking the limit 0 to 2. One can take the limits minus 2 to 2 and don't make it double. You get the same answer. See, the equation of circle is x square plus y square equals to 4 means radius r equals to 2. Hence, the limit is 0 to 2. Putting these values in the formula, pi integration a to b y square dx is equals to 2 pi integration 0 to 2 4 minus x square dx. Now, It's very simple integration. You can find it easily. What is it? 4 gives 4x minus x gives x square by 2, x cube by 3. Between the limits 0 to 2. Now what we'll do? We'll put the limits x equals to upper limit 2, x equal to lower limit 0, and we get 4 into 2 is 8 minus 8 by 3. That is 8 minus 8 by 3. Remember, you always commit the mistake in this type of calculations. LCM is 3. 3 8s are 24 minus 8, that is 16 by 3 into 2 pi. You get the answers 32 pi by 3 cubic units. Hence, what is the volume of this sphere? 32 by 3 cubic units. So remember, there can be example, find the volume of sphere. We can now in general the equation of circle x square plus y square equals to r square, where r is radius. It can be r in examination, or it can be certain number r equals to, just like we took 2, one can take 3, one can take 4. The process remains same, only there is change in the answer. So remember this problem, it is an important problem. Let us go to the next example, and the next example is here. Find the volume of right circular cone generated by revolving the line y is equals to 3 by 4x about x-axis between x equals to 0 to x equals to 4. See, it's very simple. Very simple. What is given? The equation of curve is in y equals to 3 by 4x, that is a line which is revolve about x-axis, and the limit is given 0 to 4. See the diagram. Here, this is line y equals to 3 by 4x passing through origin. X equals to 4, that is a line parallel to y-axis. It forms a triangle. If you revolve this triangle about x-axis, it forms right circular cone. Now, simply putting these values in the formula. What is the formula? Pi integration a to b y square dx. Putting the values of a, b and y square from the given equation, we get volume equals to pi integration 0 to 4 9 by 16 x square dx. 9 by 16 is constant, right? It can be taken outside the integral. X square is a very simple function, algebraic function. Apply the formula of integration of power function. What is it? Increase the power by 1, divide by the new power. It becomes x cube by 3. So, what do you get? The constant 9 by 16 pi x cube by 3 between the limit 0 and 4. Now, what will you do? Yes, putting the limits. Upper limit is, right, x equals to 4. Lower limit is x equals to 0. Which limit will you put first? Upper limit, and then lower limit. So what do we get? We get 9 pi by 16. Putting x equals to 4, we get 64 by 3. Putting x equal to 0, we get 0. Simplifying these values, we get, what do we get? Can you guess? 3 3s are 9, 16 4s are 64, and 4 3s are 12. So the answer is 12 pi cubic units. So what is the volume of the cone here? The volume of the cone is 12 pi cubic units. Understood? It was very simple equation. Similarly, any line is given. Here, the line is given. What is the line is given here? 3 by 4x. Y equals to 3 by 4x. What is the equation of line passing through origin? Y is equals to mx. Change the number, you get another equation of line. You get another problem, but the steps remain same. Only the answers change. Okay. Understood? Nice. So, let us see the next example. And the example is, find the volume of the solid of revolution when the area bounded by y square equals to x cube, x equals to 4, and x-axis is revolve about x-axis. In this example, you get the equation of curve is y square equals to x cube. Do you know this curve? What is this curve? See the example. In this diagram, this is the curve y square equals to x cube, right? This curve is called semi-cubical parabola. Remember, y square equals to x cube is called semi-cubical parabola. Now, in the example, you are given the curve y square equals to x cube, x equals to 4. X equals to 4 is a line parallel to y-axis, and therefore, this is the area between these curves, which is shown by red color. You are going to revolve this about x-axis. When it is revolve about x-axis, it forms a solid whose volume is to be found out. Now, you are given the limit x equal to 0 because it is origin, and this is x equals to 4. So, the limits of integration are 0 to 4, y square is given. So, what to do? Exactly, simply putting these values in the formula of the volume. What is the formula? Yes, right, pi integration a to b y square dx. Put these values, what we get? Pi integration 0 to 4 x cube dx. X cube is a very simple function whose integration is x raised to 4 upon 4. What is the type of function? Algebraic function. And the integration of power is very simple. Increase the power by 1 divided by the new power, remember. Now putting the limits, x equals to 0, x equals to 4. What do you get? Pi by 4 constant, 4 raised to 4 minus 0. What is 4 raised to 4? Can you find? What is 4 square? 16. 4 cube? 64. Now multiply 64 by 4, you get 4 raised to 4, and it is 256. So what do you get? Pi by 4 into 256. Now you can divide 256 by 4, you get 64 pi, and hence what is the answer? The volume of this solid is 64 pi cubic units. Okay, all of you understand? Nice. Applying the knowledge of definite integration, finding volume of solid generated by revolving the areas. And conclusion is, students can find volume of any solid generated by revolving the given area. Do you have any question?
Yes, sir. I have one question.
Yes, please.
Find volume of the solid generated when the triangle bounded by the y is equal to 0, y is equal to x, and x is equal to 4 is revolve about x axis.
Very good. It's nice example, right? It is find the volume of solid generated by revolving triangle. You form a triangle when the line passing through origin is revolve about x-axis. So here the line is given y is equals to x. You are given x equals to 4. Y equal to x passing through origin. So naturally the limit is 0 to 4. What is the formula? Volume equals to pi integration a to b y square dx. Put these values, that is pi integration 0 to 4 x square dx. X square is very simple function whose integration is x cube by 3. So pi x cube by 3 between the limit 0 to 4. Put the limits, simplify, you get the answer. Do you understand? Are you satisfied? It's very good. Now, you are fully competent to solve the problems of volume of revolution. So worksheet is given below. Try to solve it. solution of worksheet is provided for a cross verification. Now the first problem, find the volume of a solid obtained by revolving about x-axis the plane area bounded by the curve y is equals to 2 sine 3x, x-axis and ordinate x equal to 0 to x equals to pi by 3. See, it's very simple. You're given the equation of curve y equals to 2 sine 3x. The boundaries are x equal to 0, x equals to pi by 3. So what to do? Simply putting this in the formula volume equals to pi integration a to b y square dx. That is a to b is 0 to pi by 3, y is 2 sine 3x. So you get pi integration 0 to pi by 3 2 sine 3x whole square. Now here you get sine square 3x. You have studied integration. Can you tell me how to find integration of sine square 3x? Anybody in the class? Nobody? I surprised. It is sine square theta, and there is a formula of sine square theta in trigonometry. Sine square theta equals to 1 minus cos 2 theta upon 2. So using this formula, you can put the value of sine square 3x, which is 1 minus cos 6x upon 2. And now you can have very simple integration. 1 gives x, cos 6x gives sine 6 upon 6. Put the limits, calculate the value, you get the answer. It's very good. Okay. Understood? The second example was find the volume obtained by revolving the area under the curve 9x square minus 4y square equals to 36 in the interval x equals to 2 to x equals to 4 about x-axis. Do you know what is this equation? 9x square minus 4y square equal to 36 is hyperbola. Right? Parabola, ellipse and hyperbola. This is the equation of hyperbola. Anyway, what you require? You require the value of y square. So from the equation 9x square minus 4y square equals 36, you can find the value of y square, and it is 9 by 4 into bracket x square minus 4, right? Limit is directly given, 2 to 4. Putting this limit in the formula, putting the value of y in the formula, simplify and calculate, you get the answer. Right? Understood? Very good. Here, you get 56 by 3 minus 8 in one of the steps. And you are very poor in calculation of such types of fractional numbers. You always commit a mistake in examination while calculating such types of numbers. See, it's very simple. You have to apply your knowledge of school. 56 by 3 minus 8, whose LCM is 3, and therefore 8 3s are 24. 56 minus 24 is 32. Remember this. Be careful about the calculation. Don't make the mistakes. Though your answer is correct, process is correct, you are getting wrong answer and losing the marks. Now, the next example was find the volume of the solid generated by revolving the ellipse x square by 9 plus y square by 4 equals to 9 about the x-axis. We have seen the example of sphere. Similarly, here there is an ellipse x square by 9 plus y square by 4 equals to 9, which can be written by multiplying by 36. That is 4x square plus 9y square equal to 36, because you need the value of y square. You get the value of y square. You are given the limits. Putting these, what are the limits here? Minus 3 to plus 3. Right? Why? What is the equation of ellipse? X square by 9 plus y square by 4 equals to 1. 9 is greater than 4. So it is elliptical about major axis. Major axis is, right, a square is 9. So a is 3. Okay, so minus 3 to plus 3. Now, in case of sphere, I made it double by taking half part of the sphere, semicircle. In this case, you took it minus 3 to 3. Okay, it's right. But you can use the property minus a2 plus a fx dx equals to twice integration 0 to fx dx if fx is an even function. And that you did here very good. That is minus 3 to 2, minus 3 to plus 3 can be twice integration 0 to 3. You did it correctly. Now calculate it and get the answer. Now the next topic is the model is first order, first degree differential equation. The topic is concept of differential equation. We have learned some important topics so far and we hope you had good time learning with us. Browse through our online library for more content on the MSBTE website. Thank you. Stay connected. Happy learning.